Hey guys, Miss Gosling here. In this video, we're going to talk about the main sequence. By the end of the video, you'll be able to quantify the relationship between mass and luminosity for main sequence stars. So let's go ahead and get started. So let's go ahead and start by taking a look at your IB understandings, applications, and skills. So you need to understand the mass-luminosity relationship for main sequence stars, and you need to be able to apply the mass-luminosity relation for main sequence stars. So let's go ahead and get started. So as you'll remember, the main sequence is this stripe of stars that are going from the top left corner of the HR diagram down diagonally to the bottom right corner. This is where my stars that are young, so my stars that are still fusing hydrogen into helium, are located on my HR diagram. So the way that the mass-luminosity relationship is typically written is that the luminosity of a given star divided by the luminosity of the sun is equal to the mass of the given star divided by the mass of the given sun, and we're raising that quantity to the 3/5. So essentially, the ratio between the luminosity of a star and the luminosity of the sun is equal to the ratio between those two masses raised to the 3.5 power. Now, one important note is that in the IB exam, in the data booklet, the equation is actually going to be written L is proportional to m to the 3.5. And you should see this if you go ahead and look in your data booklet. You will see this equation under under option D. This is at the very last page of your data booklet. So if you want to use the equation on the previous slide, you are going to need to memorize it. Otherwise, you could just understand where it comes from, right? So if we're looking at proportionalities, when we talk about ratios, my proportionalities become equal, because saying that L is proportional to m to the 3.5, I'm saying that L is proportional to some constant times my mass to the 3.5. The luminosity of the sun is going to be proportional to this, is going to equal the same constant times mass to the 3.5, where mass is the mass of the sun. So if I divide L by L naught and M by M naught, my C's will cancel, and that's where we get that last equation that we looked at. So up to you whether you want to memorize or understand, but this equation that we talked about in the previous slide needs to be something that you were able to use. So that's the first thing. Second thing, this equation is true for all main sequence stars. So what that means is that if the star's luminosity is not proportional to its mass to the 3.5, then it is not on the main sequence. So that means it is either a dwarf or a giant, not a main sequence star. And that is really key, because one of the things you will be asked to do pretty frequently is use this relationship to determine whether a star is or is not on the main sequence. So let's go ahead and look at one example. Theta 1 Orionis is a main sequence star. The following data for Theta 1 Orionis are available. Its luminosity is equal to 4 times 10 to the 5th times the luminosity of the sun. Its radius is 13 times the radius of the sun, and its brightness is 4 times 10 to the negative 11th times the brightness of the sun. So first we're asked to state what is meant by a main sequence star. Now I did not write this on here, but this is 1 mark, so there's only one point you need to make, and we know that a main sequence star is a star that fuses hydrogen into helium. Now I do recommend, instead of doing H and HE, actually write out the names of the elements. So that's our first question. Let's go ahead and take a look at the second part. So next we need to show that the mass of Theta 1 Orionis is about 40 solar masses. So let's go ahead and take a look at that. So we know that luminosity divided by the luminosity of the sun is equal to mass divided by mass of the sun to the 3.5. So what that means is that the mass is equal to the mass of the sun times L over L of the sun to the 1 over 3.5. So we're taking the 3.5 root of L over the luminosity of the sun. So this is equal to the mass of the sun times the luminosity of Theta 1 Orionis, which is 4 times 10 to the 5th, times the luminosity of the sun, divided by the luminosity of the sun, to the 1 over 3.5, and we're going to go ahead and cancel out those luminosities. Since if something appears on both sides of my fraction, that means both the denominator and the numerator of my fraction, it cancels. And so when I throw that in my calculator, I get that the mass is equal to 39.9 times the mass of the sun, which is approximately 40 times the mass of the sun. One thing I want to point out here is that in an IB problem, or in the IB mark scheme, it is really important that you show this step here, my number before I've rounded up to the thing that I am trying to find, in order to show that I did the calculation. So what IB wants to see is, what is it equal to, and how does that approximate the answer we're trying to find? So give me one level of precision further than the question is actually asking for when you are solving the question, when you're asked to show something. So again, that key word here is show, and that show means give me one level of precision further than what the final answer is. So instead of saying this is approximately equal to 40, I want to make sure I say that's equal to 39.9 times the mass of the sun. I know that that's a very specific requirement, but it's something that it's important that you are aware of before you start your IB exam. So let's go ahead and take a look at my second example. The data for the star Eta Aquilinae A are given in the table. So we have the mean luminosity, the mass, the parallax angle, and the apparent brightness. We need to show by calculation that Eta Aquilinae A is not on the main sequence. So I know that the luminosity of Eta Aquilinae A divided by the luminosity of the sun is equal to the mass of Eta Aquilinae A divided by the mass of the sun to the 3.5. If Eta Aquilinae A is on the main sequence. So let's go ahead and take a look. So L over the luminosity of the sun is equal to 2,630. The mass over the mass of the sun to the 3.5 is equal to 5.7 to the 3.5, because my mass of the suns will cancel out. And when I put that in my calculator, I get that the mass divided by the mass, that ratio of mass of Eta Aquilinae A to the mass of the sun, is 442. That is not equal to 2630. Therefore, L is not proportional to m to the 3.5, because for main sequence stars, luminosity must be proportional to mass to the 3.5. Since this is not the case, that means we are not on the main sequence. And there you have it, guys. That is how we can use the mass-luminosity relationship to determine whether a star is on the main sequence. So let's go ahead and talk takeaways. First of all, the luminosity, L, of a main sequence star is proportional to its mass to the 3.5. If we know the luminosity and mass of a star, we can determine whether it is on the main sequence by using that relationship. So there you have it, guys. You have learned all about the main sequence of our HR diagram, our stars fusing hydrogen into helium. So it's your turn to go out and do some math. Best of luck and happy solving.